This is an AS maths question on logarithms and non-linear data. The value of a rare painting in V pounds is modelled by the equation V is equal to PQ to the power T, where P and Q are constants and T is the number of years since the value of the painting was first recorded on the 1st of January 1980. The line L shown in figure 3 illustrates the linear relationship between T and log to the base 10V since the 1st of January 1980. The equation of the line is log to the base 10V is equal to 0.05T plus 4.8. In part A, we need to find to four significant figures the value of P and the value of Q. So we'll start by writing down the equation that we've been given, which is V is equal to P Q to the power T. We're going to do log to both sides of that equation because we want to get to the form of the equation of the line that we've been given here and then match things up. So we're going to do log to the base 10 both sides. So log to the base 10 V is equal to log to the base 10 P Q to the power T. We can use the rules of logs to make this multiplication here an addition. So we'll have log to the base 10V is equal to log to the base 10 P, that's a lowercase p, plus log to the base 10 Q to the power T. We can use another rule of logs which allows us to bring this power of Q to the front. And then that will give us log to the base 10V is equal to log to the base 10p plus t log to the base 10q. Now I can match up what I've got here with the equation, which is also log to the base 10v, and use that to match up p and q. Right, so log to the base 10p, that matches with the intercept. So actually the intercept of this line here is log to the base 10p. So from that, and let's color code it, let's do this in red. We've got log to the base 10p is equal to 4.8. So if we write this log as a power, what we'll have is 10 to the power 4.8 is equal to p. Let's see what that gives us on our calculator. We get 63,095.7344, and it carries on like that. It wants an answer to four significant figures, sorry. So to four significant figures, that will be 63,100. We're now going to work out the value of Q, again by matching things up. So let's color code this. So I will have log to the base 10q, so that's the bit that's next to t, and so that matches up with the 0.05. So the next equation that I can write down is that log to the base 10q is equal to 0.05. So from here, that means that if I do 10 to the power of 0.05, that is equal to Q. So let's put that on a calculator and see what we get. And that is Q is equal to 1.1220184, and so on. Again, this needs to be given to four significant figures. So I think that'd be 1.122. So Q is equal to 1.122 to the four significant figures which was required. Part B. With reference to the model, interpret, and the first part of part B is to interpret the value of the constant P. Now interpret always means look at what the number means or the value means in the context of the question. This question is about the value of a painting and the number of years since it its value was first recorded on the 1st of January 1980. Well, when are we going to get just P in this equation here for its value? That will be when T is 0. When T is 0, basically you'll get a value of £63,100. So this is the initial value of the painting, or you can say it's the value of the painting on the 1st of January 1980. And in the second part of part B, we need to interpret the value of the constant Q. Now the value of Q is going to be what we're multiplying the value of the painting, the initial value of the painting, by each year. So each year, this number 63,100 is going to get multiplied by 1.122. So it's a bit like a multiplier that you would get when you're doing something like compound interest, except here this means that we've got a percentage increase in price of about 12.2% each year. So we can describe that by saying that it's actually the proportional increase in value each year. And finally, part C, find the value of the painting as predicted by the model on the 1st of January 2010, giving your answer to the nearest £100,000. Okay, so let's just underline that because we want to round it correctly. It's going to be on the 1st of January 2010. It starts its value from the 1st of January 1980. So that means that we're 30 years later, so T is going to be 30. So the value is going to be equal to PQ to the power of T. Now P we've got as 63,100 times by 1.122 to the power of 30. Okay, let's do that on a calculator and see what we get. So I'll get 1994412.865. So that's basically sort of about £1.9 million. Good investment, that picture. It needs to be rounded to the nearest 100,000. So that will actually round up to £2 million. Like this. So this is going to be its value after 30 years. Not bad at all.